Limits of Knowledge in a Monadic Universe. The work of physicists and mathematicians in the early 20th century introduced a startling new paradigm that suggested the human mind will never be able to achieve complete and ultimate knowledge of the universe. It's not that we don't have precise enough instruments to measure the magnitudes of subatomic particles. The blurring of exact knowledge of the smallest particles of matter is a fundamental property of the universe. It's as if nature does not want us to know everything about this ultimate level of reality. If we get too close, a cosmic trickster appears to blur, confuse, and invalidate our progress. The phenomenon confirms what philosophers and intuitive scientists have been telling us for centuries. There appears to be something else out there, some pervasive yet separate form of consciousness behind all reality that does not want to be fully known. One of the first indicators that something strange was happening came in 1905, when German theoretical physicist Albert Einstein published his theory of special relativity, which showed how events that occur at the same time for one observer could happen at different times for another observer, and that people traveling at different velocities in the universe would age at different speeds relative to each other. Einstein concluded that space and time are not separate but equivalent to each other, and united them in a single continuum called space-time. As previously noted, he also proved the equivalence of energy and matter in his revolutionary equation of E equals mc squared. Finally, in his theory of general relativity, he showed that gravity is caused by the curving or warping of space itself, not by any outside force. Einstein not only discovered the basic equivalence of time-space and energy-matter, but he also described a new paradigm in which the fundamental constants of nature were relative to the conscious awareness of an observer. Then, in 1925, German theoretical physicist Werner Heisenberg proved that exact measurement and precise knowledge in quantum physics is not possible. Specifically, he showed that the position and momentum of an atomic particle can't both be known exactly. He demonstrated that just the act of consciously observing one magnitude of a particle, whether it be its mass, momentum, velocity, or position, causes the other magnitudes to blur. This basic tenet of quantum physics became known as the Heisenberg uncertainty principle. Just 6 years after Heisenberg formulated his uncertainty principle in physics, Austrian mathematician Kurt Gödel did the same thing in mathematics with his two famous incompleteness theorems. Before Gödel, mathematicians believed everything that is true in the universe could be proven using mathematics, which is built on a set of basic axioms that are accepted as true and need no proof. Gödel showed that it's impossible to create axioms that are complete and consistent without contradictions. His two theorems state that any formal system of logic, from basic arithmetic to advanced computer programming, will be either incomplete or inconsistent. Gödel suggested the only way to understand the whole universe is from a mind completely outside yet part of the universe, a perfect description of the monad. He was the first to suggest there was a deep epistemological problem inherent in the way we understand reality. In fact, the deeper modern physicists look into the nature of reality, the more active the trickster component becomes. For example, a core principle of quantum mechanics is that atomic particles can behave like waves, as demonstrated in the classic double-slit experiment in which quantum particles passing through one slit create waves that cancel out or boost different waves of particles passing through the other slit. Their interaction creates a characteristic interference pattern, like that produced from two rocks tossed into a pond at the same time. The tricky thing, however, is that the interference pattern still occurs even if only a single particle is fired. The lone particle somehow passes through both slits at once and interferes with itself. That is what physicists call superposition. Trickier still, if we try to focus our awareness to carefully observe which slit the particle goes through, the result invariably shows that it went through only the one we measured, and the ghostly interference pattern immediately disappears. The very act of searching for verifiable data seems to collapse the superposition. Physicists can't say exactly what a superposition is without looking at it, but if they try to look at it, it disappears. We also see the cosmic trickster in the paradoxical phenomenon of quantum entanglement, in which two or more quantum particles, created at the same time, share the exact same behavior and physical characteristics even when separated by great distances. Scientists have shown that the interaction between entangled particles takes place at faster than the speed of light. Albert Einstein called it spooky action at a distance and admitted the proven phenomenon was incompatible with his theory of relativity. Once again, trying to observe an entangled particle results in an immediate and irreversible collapse of the particle's quantum wave function, which causes it and all other particles entangled with it to revert to normal behavior again.